So the first thing we are going to be looking at is what is data analytics in the first place? Okay, what is data analytics? What do we mean when we say data analytics? Okay, so we are aware of data generation. So we can look at data generation as something that happens per second. Let's just put it that way, something that happens every second. Every time you make a post on Facebook or any social media platform, anytime you like a post, anytime you comment on a post, you're generating data. Anytime you click on accept a cookie on a website you visit, you are basically um, giving out data. And even when you don't know, sometimes you see this stuff that when you log in or enter a platform or want to utilize a platform, you find out that they will give you a long list of terms to agree to. You see that data sharing is there. So data is generated every time. And because data has become one of the most valuable resource for businesses or governments and individuals alike. So every action we take, like what I've mentioned earlier, like for example, from purchasing goods online to streaming videos or even swiping a card at an ATM, all of this generates data, right? Like what I mentioned earlier, even visiting a website, posting on social media, um, engaging on social media, all of these generate data. So why it's important for people, or it is increasingly important for people to become a proficient in data analytics, is because organization collect data from their internal processes. Organization collect data from customers, customer interactions, from machines, sensors, and social media platform. I've stated that. So the volume of this data is so vast that it is often referred to as big data. Okay. So with all of this in mind, let us look at what data analytics is. We have basically seen or talked about the prospect of data, or how data is generated, how easy it is for data to be generated in today's world, or in today's digital world. So, data analytics is the process of examining the data, right? The data generated. The purpose of examining the data generated is to draw conclusions about the information they contain, right? The data set contain. So this is often done with the aid of specialized software tools and statistical techniques. So to become a data analyst is to understand data, to understand how to identify the information that is contained within the data, how to identify patterns, how to come to a conclusion, draw insights, come to a conclusion, and how to use these specialized softwares and tools, as well as the techniques, to come to those conclusions. Okay. So data analytics is that discipline of turning unorganized data into meaningful knowledge, right? So we are going to be seeing how that is done gradually. So today is an introductory class, right? So we are going to see how this is done. There is a process, or the steps that are involved in data analytics. You see, the first includes data collection. So that first step of data collection is where information is gathered from multiple sources. And because we are training you to be data analyst for organizations and not for yourself alone, we are going to be having this organizational background, right? So businesses get data from, like we've stated earlier, from customers, from processes, from machines, and so on. Their data is saved in a database. So we could get those data from the organizational database, or we could get them from social media, or it could be a transaction from transactional systems. However, the organization is getting this data. The first thing that every analyst must be involved in will be to collect data. So data must be collected. Whether you are involved in that process or not, data must be collected because it's the data that is collected that you will end up analyzing. Okay, so after the collection of data, what follows is data cleaning. So this is the process whereby you look at the data that has been given to you, that has been collected. Then you address common issues like missing values. Are there values missing within the data? Do we have duplicate entries? Entries in duplicate? Or are data or is data presented in inconsistent formats? Okay. For instance, those of you that saw what we did yesterday, which we are still going to also repeat in subsequent class in a larger way, you recall that there were some data missing, right? Some IDs were not there. We are going to still look at those even today, if really. So you see that data cleaning now involves the process of identifying what is missing, what has been entered in duplicate or triplicate, as the case may be, but still we call them duplicates, right? So a data entry that or a data that occurs more than once is what we call duplicates. So, for example, one customer name may appear as John Smith in one system and J. Smith in another. So, in data analytics, it is seen as John Smith is a different name and J. Smith is a different name. So, if uh, in the process of data cleaning you don't catch these, you will end up having analysis that is not accurate. So after data cleaning, we look at the exploration where we use descriptive statistics like averages, counts, and percentages. Then for visualization like histograms, scatter plots, or dashboards are used to understand patterns, then spot anomalies in the data. So depending on the kind of data, okay, you see that we have quantitative data, we have qualitative data. So not all kinds of data. You cannot perform average with all kinds of data. For instance, data like name, gender, those are qualitative data. And what you could get from social media, right? Those are qualitative data. Basically, textual that you cannot sum or you cannot aggregate. Okay. Can you hear me, please? Okay. All right. So now let's now go into analysis and modeling. So, depending on the objective of your analytics, right? So, analysis may include statistical tests, regression models, or even machine learning algorithms to uncover relationships and make predictions. So, just soak this in like an introduction that is this. We are going to all look at this because the goal of this class is to ensure that every participant will become a data analyst. That is not just a data analyst, but someone with the capabilities or capacity, proficiency, or someone with proficiency in data cleaning, in data gathering, data exploration, analysis and modeling, reporting and visualization and interpretation. So we will basically have a go through the complete cycle. So that is what I would like you to put in mind. Then we have the reporting and visualization. This is what is very common today, where you have people communicating analysis through charts, right? You go to LinkedIn, you see beautiful dashboards and so on. So the thing there is that the dashboard or the reporting and visualization side of data analytics, actually in business intelligence, is the catchy area, the beautiful area, right? What is not, or what they don't tell you is that there is uh, the more difficult part hidden in data cleaning. For instance, let's look at it this way. We might have beautiful charts that don't end up giving us correct insights or that don't communicate anything meaningful, right? Now, the challenge usually is in data collection, data cleaning, right? If you don't collect data that match the KPIs or key performance indicators that you would like to address, right, you will not be able to address those key performance indicators. And if you don't clean your data appropriately, you may have a count of 99 but only report 65 because the others are not counting, right? So yeah, let me give you an example. Let's say your goal, right, is to look at how customers are interacting with your product post online. Okay, say you are doing a market review. Okay, you want to look at the numbers of people who are interested in a product that you have launched. But since it's a new product you've launched, you are not looking at the numbers of people who are purchasing the product. You are looking at the interaction, basically comparing interaction in your marketing campaign with those that actually end up purchasing the product. Okay, so if that is your goal, the data you need to gather will be data of those interactions. That is the number of interactions or engagement I have in on my post on social media, right? And then those that end up purchasing the product. Now you want to find out, are they really coming from social media? Or these are just people who are used to some of your products, your other products that are trying your new product, or are there people who use similar products that want to just try your own product? Right? So to get data concerning those, you'll be looking at customer purchase history, right? You'll be looking at where they are coming from, the source, right? That is why if you want to purchase a product, some products will make you fill a form and ask you where you saw the product, who told you about the product. So this is data gathering, right? Like you're filling a form now and say, okay, where did you hear about us? Or where did you hear about the product? So the reason for that is they will want to figure out where the traffic is coming from. And once they have successfully figured that out, they know where to pay more attention to. All right. So that is it. But if we fail to get those data, let's say we are more interested in getting regional data. That is to say, where the client is coming from, where about their family size. That is the wrong time to collect such data. That will have been that will have been during say market research, right? Where we will be looking at correlating market price with those audience who say the product is developed for. Okay, so there are a lot of things that go on before the report and visualizations. But I know from my experience that most people are drawn by the beautiful charts and so on. So visualization is where insights are communicated because you cannot look at data and make sense of it. Even the analysis, okay? Let's say you've done summary analysis, okay? You cannot make sense of those analysis because you can't visually compare, right? So visualization now will enable your communication, or you enable you communicate your findings through charts, through dashboards, and through presentations, or help you even write formal reports. So it makes it easy for those looking at it, the stakeholders looking at it, whether managers or chief executive officers, to help them make decisions better and to act on your findings. So now the visualization is a reporting format, right? It's meant to communicate your findings. So I'll say this now so that when we go into visualization later on, you will remember that I've stated this before. When you the essence of visualization is to communicate your findings. So a visualization is not meant to be too technical, because remember the audience you speak with or speak to. The audience you are speaking to are not technical audience, and they need to have simple visualization or simple visuals to understand it as quick as possible, then make their decisions. So that is to say that a visualization report is meant to be simple. Okay. Now, remember, I tell data analysts this a lot. I said, remember that you are not competing with a data analyst. You are designing to what? To deliver value, which is the ease and the appropriateness of decisions that are made after your analysis. So definitely, you have to keep it simple so that your audience, who are non-technical audience, will be able to make decisions. Then, although the reporting and visualization is a communication aid, right? You also have to know how to interpret your findings. That is why it's not just enough to say I'm a data analyst, but it's also important that you know business terminologies, right? You have domains, and we are going to be looking at those domains as well. If you are doing financial analysis, you ought to be conversant with concepts in that domain. If you are doing human resource analysis, you have to be conversant with concepts in that domain. If you are doing marketing analytics, you have to be conversant with concepts in that domain as well. So interpretation involves translating complex numbers and patterns into plain business language. So your audience will want to know, okay, if I take decision A, what will I be missing for not taking decision B? Okay, basically, opportunity cost, right? If I'm going with decision B, what will I be losing out from not taking making decision A? So we have to make our interpretation so clear that everybody looks at it and makes an informed decision. Okay. So now let's look at the types of data analytics. And before we delve into the types of data analytics, I would like us to know that um, we don't apply certain instances, we don't just apply just one type of data analytics. It can be something that is continuous, okay, something that we continuously apply or apply simultaneously or concurrently in the same process. Now let's look at the first one. The first one is descriptive analytics. The descriptive analytics basically answers the question, what happened? So it's like you saying, uh, oh, what happened? Now, so the descriptive analytics, like I said, asks the question, what happened? When you look at data, the first thing you want to know, remember we said our goal of analyzing data is to find patterns, to look at basically what happened, right? Okay. So descriptive analytics now focuses on summarizing historical data. By historical data, we mean data of occurrences in the past. Okay. Like if you look at, um, say, you are doing feasibility studies, you go collect data from previous research, those are historical data, or a company looking at their previous sales data to calculate their annual returns, those are historical data. So now historical description analytics basically relies on reports, dashboards, and simple summaries that answers questions such as, example, how many products were sold last quarter, right? You can see the example I gave, right? Say a company wants to know what their sale was in quarter one of the year or quarter two of the year. So we have 4 quarters in a year. So, or what was the monthly revenue trend over the last year? So you see that every year businesses want to know their performance. Okay, so we are in 2025. So to help us plan for 2026, we will like to actually see performance of our quarterly performance. We have looked at descriptive analysis, okay, and descriptive analysis may just be us just creating a very short summary report like a pivot table analysis, which may not be clear to you now but will be clear to you later. So the second is diagnostic analytics. The diagnostic, just like diagnosis, right? You want to know why something happened, so you are diagnosing the data, basically trying to discover what really happened. So diagnostic analysis uses method like drill down, data discovery, and root cause analysis to identify patterns and correlations. That is, what are the patterns? How does it correlate? Basically, what are the relationships? What is the relationship between outcomes, or what are the relationships between outcomes? And I have an example here. I say, for instance, if sales dropped in a particular month, diagnostic analysis may reveal that it was due to delayed delivery or competitors' promotional campaign, right? So we do an analysis. Remember, I told you from the beginning, I said, this analysis, we don't choose to say, we don't just make up our mind to say, oh, we just want to do a descriptive analysis. When we do a descriptive analysis, we now have a summary, right? We have a summary of our performance over the month. Then we have low sales over in a particular month. We want to know why that happened. We want to know why we had low sales. Now, I was looking at, we were talking about diagnostic analysis and making reference to descriptive analysis when we said, imagine, right, we figured out that, okay, we did our sales, our revenue per quarter, and in the first quarter of 2025, we had our revenue for that quarter. So we discovered that there was a month, say January. In January, we had the lowest sales. So sales gradually increased, right? January was low, February was low but higher than January. March was higher than both January and February, right? So the question is, what happened, right? Why did this happen? What was the reason for this? So let's not just conclude and say, oh, it's early year, so that is why we had that number of sales. Because for businesses will want to know, what will we have done differently? What will have been the best way to communicate at that time, right? Especially if the business is not all about seasonal products. If it's about seasonal products, then we'll know, we'll figure it out and say, oh, okay. So we definitely will have higher sales in the fourth quarter of the year because, the Christmas, or if it's Easter in the in mid-year, around the first end of first quarter, we are going to see a boost in sales. So, except we have that condition. So, if we are selling a product that's supposed to have all year round peak, and in previous years our first quarter had not performed that poorly, we want to know, is it that we have competitors? Are there new competitors that we have not seen? Okay, because every business actually does their competitor analysis. They watch, everybody's watching their competition, everybody's looking at their competition. Oh, what are you doing? What are the steps you are taking? How are those steps helping your business, right? How are these steps helping your business? So what are you doing? What are the results you seem to be getting? What are we doing? Are we getting less results or worse results? So what can we do to make sure we match you or even supersede you? So that is competition, and there's that competitors analysis that is done. Okay, so that is what happens in diagnostic analysis to figure out what happened, right? Figuring out what happened will help businesses sort their issues. So the third is predictive analytics. So predictive analytics is you predicting what is likely to happen, right? Basically, you become a prophet, right? Predicting the future with historical data. That is to say that, okay, because we performed this way in this year, so 2026 will have to perform this way. Okay, so it's like you are predicting. Okay, you say, I believe you've heard pitches like, um, we have raised a revenue, we have generated revenue of 1 point something billion, and in the next 10 years we'll be at 7 point something billion. We are projected to be at 7 point something billion. So the projection, the growth projection there is analysis. Okay, they have done the analysis and say, if we can grow at this pace, the next year we will even grow, say 30% over our current growth. In the coming year, we will grow, say 60% over the 30% of the year before. So that is projection, and we don't just project just by saying it or just by wishing it. We use predictive analytics to predict those. So predictive analytics now leverages historical data, the same data you use in your descriptive analysis, but this time what you are using is that you are either using statistical models or you're using machine learning techniques to forecast the future outcomes, to say that, oh, this is our performance, or this is what our performance in the future is going to be. So organizations use this type of analytics to anticipate customer behavior, to look at anticipate market demands or operational risk. Okay, so you see that all these type of analysis is something that can we can work together with, because a company may want to know how they perform currently, right? They want to know how they perform currently. They want to know why they performed that way currently. They also want to see that, okay, if we performed this way, if our performance is like this in 2025, what will our performance be in 2026? Then we have prescriptive analysis. Prescriptive analysis basically answers the question what we should do about it. Okay, right? So it goes beyond predicting the future outcomes, basically. But what it now does is that it recommends a course of action to achieve a desired result. Let's say a business have say 30% profit margin. Let's say if our profit is not up to 30%, that means we are running in a loss, on a loss, right? So if we have a profit margin of 30%, there's something called break even, when businesses break even, right? Some businesses will tell you they break even at 3 years, some will tell you they break even at 5 years, right? So basically, every business is starting, most businesses start from the beginning, start running at loss from the beginning, because there's huge investment, conversion is low. There's huge investment, conversion is what? Low. Are you following me? Yes. So there's that huge investment. For instance, you open a restaurant. Let's say you open a restaurant. So you have, say, about 20 million, and your purpose, you want to invest in a restaurant. So what happens now is that you use the 20 million in setting up a small restaurant, beautify it, and put everything together to make people come to your restaurant. So what happens is that in the first year you have used 20 million. You look at it, it's not possible to sell, to say, okay, you want to make up, you might say it's not possible to make up the 20 million, and that 20 million may even be outside your running cost. So you are going to put your running cost, your every cost together for 5 years. That is, you are going to pay employees. You know that you are not going to generate that profit in the first year. You're not going to start making profit in the first year, because you're looking at this. So let's say everything, including running costs, is about 50 million. You basically know that you may not make 50 million in the first year, and know that in the first few months sales will be slow. So why make those projection is because you want to actually factor in issues like people may not know that you're there. Then you need to increase promotions and so on. At the beginning, you need to give discounts and so on, allowing people to basically, because of the skeptical nature of customers, you want them to see and to test your service, right? So that they can be your loyal customers. So now you have done that. You have done that. You see your performance, right? You've done descriptive analysis. Okay, this is the first year. How much have we made? Okay. So let's say you made say 4 million in revenue. If you make 4 million in revenue, the question is that how long will it take me to balance, right? To be that, okay, I've gotten my 50 million. We are basically starting at ground zero with the assets that we have to continue making money and making profits. So, the thing is that young businesses or startups can easily say that, oh, our goal is to break even at 5 years. Our goal is to break even at 3 years, without actually studying it analytically. Is this possible, or are we just wishing, right? It's possible you are wishing, right? Okay, that is why you see young startups will go study businesses, ask questions, get data, and say, okay, how long did it take you to break even? Right? It's just like questions you see people ask, and somebody will ask you this question: you made 300 million in 1 year. How was it possible? Now, the first time I heard that question in an interview, I was like, Oh, people have not understood yet. It's not possible to make that 300 million in 1 year. You know why? The thing is that it's not that you didn't make a 300 million in 1 year, but it began behind, right? You started, customers started trusting you. You put in huge revenue, people started knowing you. So there was a lot of work you put in. So it wasn't that, okay, you just started a business in 2025, then in December of 2020, in December of 2025, you got a 300 million. It's like this. You started a YouTube channel. The YouTube channel, you figured out at the beginning of the YouTube channel, subscription is slower than when the algorithm already know you, understand your sequence, and when people can recommend you. So that is how it is. So we have gone from descriptive analysis to diagnostic analysis. We have predicted that it take us 5 years to begin to make money. Then the prescriptive analysis is that, okay, what should we do so that in 5 years we should make the money? So it combines data insights from optimization and simulation techniques to suggest actionable strategies. So this is where we actually develop strategies to say, okay, what we are going to do is that we are going to implement strategy A, strategy B, strategy C. Are we implementing A first, B following, and C, or are we implementing them simultaneously? So what is it? What are we going to do? So that is that part of the analytics that does that for us. So if you have any question, just open up your mic and speak, because I'm projecting so that we have a clear recording. Okay. So now we have basically looked at the types of data analytics, and we have agreed, or we can agree, right, that all of these are either a sequence, right, or in some cases you don't have to do a prescriptive analysis. It might just be okay to do descriptive and diagnostics, depending on what was requested of you to do, and depending on your recommendation, right? Sometimes you don't get to look at strategies. Sometimes you end in predictive analysis, while the strategists or business strategists go ahead to use your data or insights you've generated for that. So let's go to data analytics roles. You see, if you search for, say, uh, you get a job as a data analyst. You see, when you search, you will see that you have several roles out there, several roles out there. Okay, so now the first is data analyst. Okay, you hear many people tell you they are data analysts. So what are the responsibilities of a data analyst? Okay, so the data analyst is the entry point to data professional. Okay, is the entry point to the data profession. Basically, is the entry point to the data profession. So the primary responsibility of a data analyst is to clean data, to explore and analyze data sets in order to uncover meaningful patterns and trends. Okay, as a data analyst, you'll be working directly with data. You will be correcting errors, you'll be handling missing values, you'll be ensuring that data is ready for analysis. So once the data is prepared, the analyst creates the reports. You can go ahead and create dashboards and visualization that will help businesses and stakeholders understand what data is saying. So we are going to look at tools later, but let me just add this. So data analysts frequently use tools like Excel for quick analysis. You have SQL for querying databases. Then you have Power BI or Tableau for creating interactive dashboards or reports. Okay. Then we have the business intelligence analyst. The business intelligence analyst has a role that is closely related to the data analyst, but with stronger emphasis on business strategy and decision support. That is why, as a business intelligence analyst, you have to know key performance indicators. So yours will be going as far as reaching prescriptive analysis. So um, you will be strong on what? Business strategy and decision support. So basically, might be okay for data analysts to just know descriptive analysis and diagnostic analysis. It might just be okay, right? But for a business intelligence analyst, you have to know up all to prescriptive analytics. Okay. So the tools that the business analyst will commonly use, the most common is Power BI and Tableau. Those are the most common. But basically, because the business analyst major role is for dashboard designs that provide high level overview of company performance. So that is why those two tools we have we have others as well, many others. Okay, so let's look at this example. For example, a BI analyst in a financial institution may create an executive dashboard that shows revenue versus target, customer acquisition rates, and loan default percentages. Okay. Now, in that same industry or in that same company, a data analyst might focus on detailed operational metrics, right? While the BI analyst will ensure that insights will align with strategic objectives rather of the organization. So it's close, but the business analyst is strong on the strategy side. So we have the data scientist following. The data scientist role represents a more advanced level of data analysis. So data scientists go beyond they go beyond descriptive reporting. They build predictive and prescriptive models. They build what? Predictive and prescriptive models. So these two, they are very strong on these two, right? Remember, I would say the data analyst may just know one and two and may be fine. The BI analyst may know one, two, and four and is fine. But the data scientist will have to know one to four. That is, be very good at one to four. Okay. Then we have the data engineer. The data engineer ensures that data infrastructure itself is reliable, that is scalable and efficient. So, data engineers are the ones that develop or design and maintain data pipelines, data warehouses, and databases that make raw data accessible for analysts and scientists. So it's like they're like engineers, okay, or who build roads or plumbing systems that will allow information to flow seamlessly through an organization. Okay, so there's the two data engineers frequently use include SQL. Then they are strong basically on the ETL part, that is, they extract, they transform, and load data. Okay. So then we go to the fifth, which is specialized roles. In specialized roles, you can have database administrator who is responsible for managing and maintaining databases. We have data steward that ensures organization data complies with governance policies. We have machine learning engineer, okay, who focus on deploying machine learning models into production. So, like I said, we have a detailed notes for you to go through and understand that. Mind you, if you have any question, you can ask. If not, you can jot them down and ask on the learning platform. So we had looked at the common tools. Basically, when we're talking about the different data analytics roles, we look at tools that or common tools that each role use. So let's just look at the tools. Look at an overview of these tools. So for data handling and preparation, we use Excel. You can use Excel or any other spreadsheet. You use Power Query, right? Power Query is used for data cleaning and transformation. Then there are other ETL platforms. ETL just means to extract data, transform, and load. You can also perform ETL with Power Query, right? Okay. Then for data storage and query tools, we have the SQL, that's the structured query language, right? For different databases, right? Which we can use in databases like MySQL, Postgres, Oracle, Microsoft SQL Server, and many others. So for cloud data warehouses, you have Google BigQuery. I believe you have heard of these in the. If you are conversant or use YouTube a lot, you see that they have ads on BigQuery. BigQuery is from Google. We have the Amazon Redshift and Snowflakes. Okay. Then for statistical analysis or statistical and programming tools, basically, we have Python, right? We are going to cover Python. We have R, we have SAS and SPSS, okay? For SPSS and R are very good for statistical analysis. Or even Python, we have libraries in Python that is good for statistical analysis as well. So for visualization and business intelligence tools, we have um, Power BI, which is very common in this climb, and Tableau. Okay. So for big data and cloud tools, we have the Apache Hadoop, we have Spark, we have cloud platforms like Amazon Web Services, Azure, and Google Cloud. Okay. Can you hear me, please? Okay. Are you following? All right. So, why is data analytics career, or why are careers in the data analytics profession growing? It's growing because of several factors, but we've just captured three here. The first is explosion of data. That is, we are in the big data era. So every day, uh, businesses, individuals, we generate vast amounts of data through digital transactions. Like, let me give this instance. In Nigeria here, we have OPay, for instance. If OPay tells you the number of transactions that is carried out in a day, it will be shocking. It will amaze you. Or even the normal banking systems and so on. If you look at the back end, your analytics on social media, it will amaze you. For instance, you look at the number of people your post reach, it amazes you. That is why you know that, oh, probably you've not made the right post, your post is not engaging enough. Probably that is why you don't have as many engagement. But you look at um, insights like impression, you see thousands of impressions on your post, right? If you look at reach, the same, thousands of reach on your post. Majorly, you see engagement metrics like click through rate, and what is it called? Views, likes, and comments may be low depending on how engaging your post is. Okay, so generating data today is very easy because you have interactions. You can see from your post who and where interactions come from India, from US, from you basically can see from anywhere. You can data generation is very easy in this big data era. So the second is shift to data-driven decision making. It's very uncommon today for businesses to just on the whim and say get up and say okay, let us make changes strategy. Every strategy today for those that are serious or businesses that are serious are backed by data. Okay, they are backed by data. That is why today it's important that you know the quality of data that you gather. The quality of data that you gather depends on or determines your what is it called, your the quality of your analysis. It determines the quality of your analysis. So if your data is not gathered properly, if it's not gathered properly, you will have poor outcomes. And if your outcome is poor, then your strategy is poor. So now retailers use customer analytics to optimize product placement, right? You see, for instance, let me give you this very simple example. Let's say you Google a product today. Google a product. I'll share this stuff with you. Not long ago, while watching these adverts, I wanted to click skip. I wanted to click skip on YouTube, but I didn't get the skip button, so I just clicked on it and it opened. It was a loaning app advert. So one of these loan apps advert. So as I clicked it, the truth is that everywhere I went, everywhere I want to Google something, they are there. I open Facebook, it's like they are there. They're just following me everywhere. So that is what data does. Okay, so businesses are shifting to this. So the need for data analysts is growing and will continue to grow. Will continue to grow. The thing there is that um, I would recommend that instead of just be an analyst, you see how you walk into trying to be a data scientist that create models because most times you don't want to remain where you do what where you perform descriptive analytics and diagnostic analytics alone. You want to be able to what um, uh, perform predictive analytics and prescriptive analytics as well, so that you will find use in the industry. Okay, because if we can basically create a model that will do those, so I don't have to analyze every day. I work with data engineers that will create a pipeline and will develop the model for this analysis to be carried out. So basically, we have automated the process for decision making easy. So until we are able to get to that point, you find out that it's like we may not get as much value from just being data analyst. Okay, from just being data analyst. So that is why we say data analysis is the entry point, or data being a data analyst is just like the entry point to the data profession. Okay. Then we have integration with emerging technologies. So with the rise of artificial intelligence and machine learning, cloud computing has expanded the scope of analytics. So professionals with hybrid skills in analytics and AI are now in high demand for developing intelligent systems that can predict, recommend, and automate decisions. So this was what I was talking about. That is not enough to just do data analysis, but it's important that you actually start from data analysis and you know you're heading somewhere. Okay. The career roles and paths. So these data roles we talked about. So the data analyst is the entry to mid-level role that is focused on cleaning, analyzing, and visualizing data. They use tools like Excel, SQL, Power BI, or Tableau, right? Then for business intelligence analyst, the focus on the focus is on designing dashboards and key performance indicator reports for decision makers. So they work closely with management to align analytics with business strategy. So they use visualization. They use visualization tools like Power BI, Tableau, Qlik, and SQL. SQL is for the database, right? So, but a business intelligence analyst can still include Excel. Okay. So then data science basically occupies advanced role that requires statistics modeling, machine learning, and programming expertise. That is why if you were in the data analysis class, what we'll have started with will have been statistics. Then we'll look at mathematics, right? Then we go ahead. So data scientists are involved in creating predictive and prescriptive models. They use tools like Python, R, TensorFlow, and PyTorch. So we are going to include Python in our learning. And the reason is this, so that when you progress from data analyst rather, business intelligence analyst, you can easily progress to data science, okay, because you know how to use these tools. So the data engineer now builds and maintains data. Okay, so I the data engineer builds and maintains the data infrastructure that supports analytics. They ensure clean, reliable, and scalable data pipelines. So the tools that I use include SQL, Python, and so on as we have there. So for specialized roles, we have machine learning engineers we've talked about. We have database administrator, data governance specialist, and chief data officer. You can have more depending on the organization that and what their needs is like. Okay. So for the career progression for data analyst, you can begin as a data analyst, then grow to senior analyst, then analytics manager. For data scientists, you can begin with data scientist, then lead data scientist, then AI and machine learning researcher. So the progression depends is determined by the organization that you're working for and their needs. Okay, but the data profession is an interesting one. It's a growing one that needs constant adapting because of the evolution that occurs within that space. Okay, so I want you to prepare your minds. I want you to prepare your minds. I want you to know that you started something that will change your life. I want you to open your mind, study very well because will expand the way you think, will require you to do a lot of things. So don't shy away from asking questions. Ask your questions during the week. Practice. Don't keep it and say, "Oh, I will do it some other time." I want you to create a habit where every day you do something concerning your interest in data analytics or the data analytics profession. I want you to consciously do that every day. You say, today, I have to look at this. I have to look at something that relates to data today. I have to look at something that relates to data tomorrow. So you have to do that so that it builds into your subconscious, okay? So that it controls your conscious. The truth is that how badly do you need it, right? We often want a change in life. How badly do we want it? So that is it, and that is what I have to say. So let's look at types of data. Like I told one of you, I think is Merit. I told her, I said, okay, the truth is that we are going to look at types of data, but as we progress into handling data, we are going to basically look at data types, right? So that will give us clarity. But for now, let's look at data types of data based on the structure of data. Okay, how is data structured? Let's look at it. If we're looking at how data is structured based on the types of data, we'll be looking at structured data, unstructured data, and semi-structured data. Right. So let's look at this. Uh, in depth. So the structured data basically is data that follows a strict format that is organized in rows and columns, just like you have in your database, your spreadsheet or your tables, right? Where you have gender, right? Something like this, okay? You have a customer ID, name, age, country, sign up date, purchase amount. So this basically will serve as a data that is structured because a structured data is easy to store, right? Structured data is easy to store, it's easy to search, and you can analyze it in tools like SQL. So examples like what I showed you here, examples could include customer name, phone numbers, addresses in customer relation management systems, or transaction records in bank database. For instance, if you request for your bank statement, you are going to see the transaction ID, you are going to see the transaction name, you are going to see the transaction date, and you are going to see comments. So all of those data are structured in a way that is easy for you to retrieve. Remember, to retrieve. So the most easy data to analyze is the structured data because it's easy to retrieve, it's easy to analyze, easy to filter. Okay. Then we go into unstructured data. We said something about the rise of data or the increase in data that is collected today. And one of the things we mentioned or where data is generated is social media. We have a lot of data generated in social media. For instance, if you were asked to do a sentiment analysis for a product launch, you will not be looking at data from purchase. You'll be looking at what people are saying concerning your launch, your product launch, right? You'll be looking at that. So where do you get those data from? You get them from social media. So, and this data is in unstructured format. So you have to, they don't have predefined format. For instance, the format of engagement in LinkedIn is different from the one in Instagram, different from Facebook, Twitter, and TikTok. So they are different, as well as Pinterest. They are all different. So that is what makes them difficult to analyze directly without pre-processing. That is to say that you have to process them into structured data. So you have to align the sentiments, or basically what you are looking at, what your interest is. You have to look at them from those posts, the comment, the likes, the engagements, and so on. You have to now structure them so that you'll be able to analyze them. And that's what we call pre-processing. So examples will include emails, social media posts, images, audio, and video files. For instance, there are interviews. There are sometimes you send field analysts to go to collect data from interviews, say street interviews. Many times you've seen where people will be asked about a product, like, okay, how do you feel about this product? And the person answers. The person is not, it's an open-ended question, right? So the person is not answering based on any direction. It's just saying what they feel. And you'll be amazed that two or three people will be saying the same thing, but within those they have very different, in summary, the same thing, right? They're either saying they like the product, or they say they don't like the product. But those that say they don't like the product may compare with product they like, and they will tell you that, oh, they prefer this product because of this and that and that. So you will not just end up and say, oh, those that like the product 10, those that don't like the product 10. You end up saying that. You pick those points within those interviews, right? You pick those points within those interviews and you go with them. Then, unstructured data can also arise from customer reviews in free text format, where you have basically open ended. You allow people to write and pour out their minds so that you basically get. So, unstructured data are actually better. That's why we say we use unstructured data for sentiment analysis, because you can deduce, right? You basically are giving people the freedom to add their opinions. So because of that, it's easy for you to get real deal with from the data. Then we have semi-structured data. The semi-structured data is data that have some organizational structure, but is not as rigid as structured data. So examples will be JSON files, XML documents, web logs, and sensor data streams where values are tagged but not stored in tables. Okay, so now we want to use this to explain data structures, that is table rows, columns, and keys. Let's explain this now. So if we look at this table, this represents a structured data, right? If you look at this, you see that our data is organized in columns and rows. So the entire table, the entire column and rows come together to form what? The table. Then we have the column, that is the customer ID, the name, the age, country, sign up date, and purchase amount, all being columns, right? Then the rows now, the rows here represent individual customers within our table. So that is a full data will be from each row. Excuse me. So thank you. So now we have customer ID one. So if I say I want to pull out the information of customer ID one, I'm going to get the customer name as Alice. I'm going to get her age 25. I will know where she is resident in the US. I'll know when she signed up, and I know when she purchased the product. So that is why we say that the columns basically serve as, I'll say, variables, while the rows serve as individual uh, customers in this case. In any case, individual entry. So that is how it goes. So now for keys, this will be very important for us when we begin to look at modeling. We'll look at primary keys and foreign keys. Now, in modeling, let me just give a brief explanation or introduction to modeling. In modeling, modeling helps us to kind of model our tables, right? We may have dimension tables and fact tables. Fact tables hold the transactions, basically our transactions, right? Then our dimension table may be customer table and employee table, depending on that, or even dates table. So now in this table, we have customer ID, right? In the customer table, we will have customer ID. So in the customer table, we have customer ID, but in that customer table, the customer ID is the primary key, is the main key that we use for our to connect one table to the other. Now, the foreign key, this customer ID will be a foreign key if it appears, say, maybe on the sales table, right? If it appears on a sales table, it's going to be a foreign key because of what? It is foreign to that sales table because that sales table has a primary key, which is the sales ID. So if you're not clear, just hold that thought there, and when we look at that, it will be very clear. Okay. Now, very soon we'll be rounding up this class, but before we do, let's look at common data issues. The common data issues, if you look at this, let's just go back a little bit now and look at this. If I point out here, there are some common data issues here. There is no customer ID for this last individual, Mallory. We don't have a customer ID. Then when it comes to age here, you can see that we also have missing values here for age. Then instead of having this age as 30 in numeric, we have 30 in words. That is one of the data issues. So we have seen two missing values and inconsistent formatting. When you come to the date or the country, you also see inconsistent formatting in Nigeria. So this Nigeria and this Nigeria serves different purposes. You read them, you know it's Nigeria, but it will not be analyzed or counted that way. So we have to standardize these, either go with this Nigeria for all or this Nigeria as the case may be. Similarly, with Canada, we have Canada representing the same thing. So we cannot pick this Canada and leave this Canada. So we have to standardize them to make sure that they are basically the same thing. Okay. So that is another data issue. So this is the similar data issue is what was in the age and the purchase amount. Then inconsistent formatting. Look at the date. The dates are not formatted the same way. So we will have issues there if we don't. We'll have issues if we don't address that. Okay. So let's explain them more now in details. So missing data, we have data or records with blank fields or incomplete values. Say example, a customer's phone number missing from the database. The customer is there, every detail is there, but the phone number is missing. So that phone number represents missing data. So we have duplicates. Duplicates means that we have the same record stored more than once. Example, we have two identical entries for the same customer order. If we look at this here, you see that we have customer ID 2 and customer ID 2, right? You see that all the details are exactly the same. But I want to say something about missing data. Sometimes in some situations, okay, we may have repeat purchases, right? Where we have the same customer ID, but the customer ID is purchased, the customer is purchasing different product, right? And at different time, at different dates. So that will not mean duplicate value. So we have to be very careful with what we identify as duplicates. Then inconsistent formats. So we have looked at that inconsistent format with dates and those figures. Then outliers and errors. Outliers are values that are unrealistic or incorrectly recorded. Let's give say an example. A product is recorded with a price of $10,000 instead of $100. So that $10,000 is an outlier. Okay, it's an outlier. An outlier distorts the true center of tendency. It doesn't allow us get an actual mean or a good representation of what the mean would be. So, for instance, you are studying people, say from 1 year to 45 years, but you have 97 years, and maybe as a result of or the errors as a result of data entry, well, but those are outliers. So outliers may not just be something that is larger than your margin. It may also be something that is less than your margin. So basically, something outside your margin. Then the fifth data issue or data quality issue is data redundancy, where you store the same information in multiple places. It's unnecessary, okay, and it can lead to inconsistencies if not updated everywhere. So while save data everywhere, where you can have a central database that can be updated, okay, so you don't forget to update employee module or HR module, and you remember to update you update what say accounting module, but you forget to update employee module. That is to say that, for instance, the number of say when an employee leaves an organization, you forgot to remove that name there, but you removed it from the accounting module, right? So why have several modules when you can have one module? You can have several tables from one module. Okay, then let's look at ethical consideration in data analytics before we go into questions and answer. So, number one, data privacy and security. Data is very important, right? Even as you see data is generated, when you want to create a social media page, they'll tell you how your data will be used and will basically be used and sourced. So you agree to the terms of condition and you have it. So before we go ahead and agree to terms of condition to because we just want to look at allow to pass that stage, we should be careful about what we agree. And even while you save your passwords online, you should be careful as to what you agree to. So, and you as data analysts, you have to remember that the data you work with are highly private, and you can be sued or go into legal disputes if you use the data for something that is not was not meant to be used for. Then we have bias in data and algorithms. So data can reflect historical or social biases, which may get amplified. We use in algorithms. So, example: a hiring algorithm trained on past data may discriminate against women if the historical data underrepresented them. It's like that, right? The algorithm may say, "Oh, because I was trained with historical data, and the historical data favored males, so I will favor males." So that's one issue. If you favor females, you favor females. Okay, so that is an ethical issue, something that machine cannot take away from human reasoning. Okay, because it's based on what they are fed, they will basically give you the results. So basically, garbage in, garbage out. So then the third is transparency and explainability. So many machine learning models, especially deep learning, are often considered black boxes. So we must be able to balance predictive power with the ability to explain results to non-technical users. I've stated this is a huge problem, right? It's a huge problem. And I see data analysts want to be highly technical. And I keep asking this question, and I'll continue to ask the question. It's like say two restaurant owner opposite themselves in the street continue to say uh, please, can somebody help me with a French cuisine? Anybody that knows a French or Italian cuisine or Chinese cuisine? Anybody with a name? Hello, can you hear me? All right. So, can you help me with a French, Italian, or Chinese cuisine that you know is uh, okay? While I wait for your contribution, there was a video I watched long time ago. a long time ago with Shei Law and what's her name? So the lady just went into a restaurant and called a kind of fancy name, right? He said she wants to be served that fancy name. So she asked Sheilo and said, "Okay, will you? What do you want to order?" Sheilo wanted to order pounded yam, right? And so they he now went ahead and said, "Okay, give me the same thing." When she brought it, Sheilo found out that there were salads and I think some pork. So, but he didn't know he was eating it. He was eating it that in the skit, right? He was eating it, and before you knew it, she was the lady was asking, "Are you enjoying it?" He was like, "I'm enjoying it," basically pretending, right? So when he said, "Let him ask, what is this?" and he say it is cooked pig's blood. Ah, he was mad. He was angry. Why will he be eating pig's blood? Anyway, what I'm trying to point out is this: it's like two restaurant owners instead of communicating with the customers, telling the customers what they have in their menu, they keep throwing words at themselves to call the items in the menu fancy words. So basically, the clients will not or customers will not understand what you have. So it's like that with data analysts. Data analysts are often very technical. They want to talk about what they have been able to do with it with using technical terms, forgetting that the audience they serve are non-technical audiences. So let's look at the fifth one. Last but not the least, data misuse. Data misuse is a serious issue. Okay, if you use data for the purpose that it wasn't meant for. Okay, you don't use manipulated. There's ethical advertising, right? Even when we look at strategies we use, we have to ensure that we recommend strategies that are ethical, especially in advertising, and doesn't is not discriminatory. Okay. All right. So, thank you. We have come to the end of this introductory session. Both slides and the material will be shared with you. So, I would like us to ask questions. If you want me to move to a specific slide, let's do that. We have 10 minutes to address that. Okay. Hello. My guys are here now. Hello. Can you hear me? So, no question. Faith, ask me question. Ask questions and get 5 marks. Okay. Hmm. Yes, please, I can. Okay. Yes. Hmm. Yes, you have to take a different course, but it will not be as difficult as it will have been if you have not taken this. What is very important, for instance, if you look at for data science, you look at regression models, you look at machine learning models. So you have to learn how this work. You have to learn statistics before you even you basically learn a model like regression the statistics you have to basically learn regression model where you work you calculate right so you learn that then some mathematics as well but thank god for tools available today so you don't have to go so deep as it will have been previously so you have AI artificial intelligence that can help you grow. So basically, you can get the basics of data science, know the concept terminologies to use, then you begin to learn basically on the job. So, answering that question now, I've trained many people, and I know one issue that people have. The issue is this: I don't think I've learned enough. I don't know enough. That's because people usually search their head, right? When somebody asks you, "Are you a data analyst?" Before you respond, you want to search within your head, like, do I have prepared answers? Okay, what if this person should solve this problem? Do I have prepared answers? The truth is that I don't think you ever find that in your head that you have prepared answers. The willingness to try will bring out what will surprise you. Hmm? So I don't want any of you to feel like, oh, I don't know enough, or when I know enough, I don't want that. I don't want that. I have trained, like I said, many people, and those that have agreed that they can try are those that are enjoying it. Okay. You have, for instance, let's look at areas where you have missing values. Let's say, for instance, you have multiple missing values here. Let's assume that this Bob was not a duplicate. It was another. Let's assume, say, it was Stephen, right? So we have 25 here. If I, like I showed you in the last class, if I do a fill down, it will be 25, 25. So assuming we have like, okay, we just have 11 data here, 11 customers. And in these 11 customers, the age is missing like five already. So this, if I'm to get the average of the ages, it's not giving me a true value, right? Because I've basically just copied Alice's age across, right? So it may not give us a true value. So when data is missing a lot, like say an age data is missing too much that we cannot actually do something about it. The question is, should we even use age as part of that analysis? We may not use age as part of that analysis, okay? We'll use others because there is no technique. It will be like we are just filling up using, we can use average, for instance. If we use average, it's still going to be the same age. Let's say we look at the average of these, we are still going to be putting the same values. If we use the median of it, we are still going to be getting fixing the same values. So it all boils down to you, to your discretion, right? You make the point that there's no actually one correct thing to do. It's just you telling yourself that, oh, I am missing too many data points here. I don't think I can use age. Okay, is that clear?